Hi students, today we will learn about amine synthesis. The CX disconnection used for ethers, sulfides, etc. is not satisfactory for amines. The problem is that the product 2 of the reaction is as reactive as the starting material 3 because of inductive effect, and this reacts further to give 4 and 5. So here you can see how the starting product is you can see that it is it is as reactive as the starting material. The first product which is obtained is as reactive as the starting material, and this can further react to give 4 and 5. So there is it is not that a final product is obtained, but this is going to be a continuous process, so wherein it can lead to byproducts and not a desired product. So it is of no use adding one equivalent of methyl iodide, since the first molecule 2 formed in the reaction will compete with the starting material for methyl iodide. Thus, alkylation of an amine with an alkyl halide can occasionally be used if the product is less reactive than the starting material. The solution to this problem is to avoid alkyl halides and to use electrophiles, which give relatively unreactive products with amines. So some examples are acyl halide, aldehyde, and ketones. The product amides 8, 10 and 10, that is imines, can be reduced to amines. So here you can see that instead of using an alkyl halide, we are using an acyl chloride or a ketone, or also it can be aldehydes, which react with the amine, and the intermediate that we are getting is the unreactive unreactive amides and the imines. So these are highly unreactive. It is not like you are adding a alkyl halide and getting a first product which is going to be reactive from the with the starting material. But here these amides and the imines are less reactive, and this can be further reduced to give the target molecule. So we can adapt this technique, that is of using acyl chlorides, acyl halides, and also ketones or aldehydes. A preliminary function group interconversion is necessary before we apply the CN disconnection. See, all amine synthesis definitely need a functional group interconversion, and after that we are going to disconnect the CN bond. Amine 12 could be disconnected by either method A or method B. So here we can disconnect this target molecule either in the junction A, either with the A type or B type, but both need the functional group interconversion. So when you're when you're doing the functional group interconversion of B, then you are going to get the imine, and when you're doing the function group interconversion of A, that is CH to NH2, we are going to get CONH. So this is how we are going to reduce. That is nothing but CONH on reduction is going to we are going to get CH to NH2, and imine on reduction is going to give rise to CH to NH2. So this is the meaning. So that's the reason why we write the reverse, that is reduction. So we're writing down the reduction. This already we have discussed in the first slides itself, that whenever you're doing the retrosynthesis, we're writing the reverse of reaction. Actually, it is that the starting material on oxidation is going to give rise to, the starting material, the starting product, or just the intermediate on reduction is going to give rise to the target molecule. So, but since it is retrosynthesis, so we are writing it as reduction. Okay, so this is the reverse, and here we get the amide, and we are getting imine as the intermediate. So now here you can see that how CONH bond we are disconnecting, we can disconnect, and we can write down as CN disconnection. And we know whenever we have amide, we can always disconnect the CN bond, because once you disconnect, we are going to get the synthons, and the synthetic equivalent is going to be an amide and an acyl chloride. So we can use this acyl chloride and amine as a starting material, and we can we can get back the target molecule, or we can use the starting materials to obtain the product, that is the target molecule. Now when you take the imine, so imine is also a good intermediates which are unreactive, and these are stable, and this can further, you can do the CN disconnection. Once you do the CN disconnection, we're going to get a ketone and a amine. So a ketone and an amine can be used as starting material, and we can get the imine, which on further reduction can give rise to the target molecule, which is the product. So we can use this kind of the intermediates, and the synthesis is also given here. Next, let us look at some of the amine synthesis for primary amines. So unsubstituted imine, that is 15, are unstable and cannot usually be made in good yield. But primary amines can still be made in a one-step reduction amination in which the imine is not isolated. Primary amines are not usually made by reduction of amide, but they use other reductive processes. So primary amines, we do not use amide as an intermediate, but we are using different methods, different other reductive processes. So let us look at that. So for unbranched amines, we can reduce cyanides. So this method is suitable for benzylic amine, since aryl cyanide 18 can be made from diazonium salt, and for homogeneous amines, since cyanide ion reacts easily with benzyl halide. So hence we can use this method of using a cyanide as an intermediate, because we can easily we can do the disconnection, we can easily get the amine. So this is a good intermediate which you can use, or this can be used as the functional group interconversion whenever we have primary amine. Okay. Next, for branched chain primary amines, oximes are good intermediates since they can be made easily from ketones, and during the synthesis of this target molecule, reduction of oxime cleaves the weak NO bond as well as reduces the CN bond. So we are using, so for branched the chain primary amines, we use oxime as an intermediate. See, when we do the function group interconversion of this branched chain amine to the oximes, so here oximes, you can see that you can disconnect, you can do the CN disconnection here, and once you do the CN disconnection, you can easily get the ketone and the amine. You can get the ketone and amine, and ketone and amines can be used as the starting material, which can be used that is, when you use these two starting materials, it's going to give the oxime as intermediate, and oxime on reduction, see, the nitrogen and oxygen is a weak bond, so you can easily reduce the NO bond, and simultaneously also the cyanide bond is getting reduced. So once it gets reduced, that is NO bond and also the cyanide bond, we can easily we are cleaving the NO bond, and also the reduction is going to take place at the cyanide. So once we use this hydrogen as a catalyst in presence of palladium or the lithium aluminum hydride, we can get the target molecule. So this is how we can do the synthesis for amine synthesis without using alkyl halides as the intermediate, but by using acyl chloride and also ketones and aldehydes as the intermediate, which can give rise to a stable synthones and the reagents. Now there are certain other routes to amines for the reduction. Aromatic as well as aliphatic nitro compounds can be reduced to give the corresponding amines. Azide can also be reduced to amines. The importance of this reaction is that azide ion acts as a reagent for NH- so that the disconnection is a normal one for CX bonds. So in place of using any other intermediate, we can also be using azide as an intermediate, because N3- azide can be used as a reagent for the reagent for this synthesis. Hence, we can, in place of using an acyl chloride or a ketone or an aldehyde, we can also use N3- as a reagent. So let us look at this reaction. So here, a target molecule of this kind can therefore be made by reduction of azide, which can be derived from epoxide and azide ions. So here, this is a different, it is not... so in this example, it's a different kind of an amine. Here, what we are doing is we are doing the interconversion to an azide. That is NH2 group, we are converting to N3. Now we can cleave the carbon and the nitrogen. And here you can see that it is a 1-2 disconnection, because hydroxyl is having a 1 that is the carbonyl carbon attached to the hydroxyl group is numbered 1, and the adjacent carbon is number 2. And here, since it is we are disconnecting the CN bond, we are writing it as a 1,2 disconnection. So once we do the 1,2 disconnection, we are going to get the azide ion and also the epoxide. That is Ampolong reagent is being used here, because what happens is nitrogen is going to get the minus charge, and once nitrogen, that is N3 is getting the minus charge, the azide ion. And when you look at this hydroxyl synthon, what's happening is the carbon which is attached to hydroxyl is having positive, and that next carbon should be having negative. But here what happens is it is going to get a positive charge. So once this carbon gets a positive charge, what happens is the oxygen is going to form a bond to give rise to a cyclic structure, that is a oxygen in it, that is nothing but the epoxide. So now we can use this epoxide and the sodium nitrite, and we can get the intermediate. The intermediate has the azide in it. Now on for the reduction with hydrogen and palladium, only the N3 is, that is the azide group, is only going to get reduced. Once it gets reduced with lithium aluminum hydride or hydrogen palladium catalyst, we are going to get the target molecule, which is nothing but the amine. So these are some of the examples of how we can use, how we can disconnect nitrogen, how we can disconnect target molecule wherever the target molecule has an amine, that is a primary amine or a secondary or a tertiary amine. How we can make use of how we can avoid making use of alkyl halides, and instead we can make use of acyl chlorides, ketone, aldehydes, and also azide as a intermediate, so that we can get a unreactive intermediate, and it can give rise to a suitable starting materials which can be used to form the products. So this is about the amine synthesis. Thank you very much.